also from Robominers.
I'm Evan, I'm from Theta Robotics.
I'm Ryan, I'm from Yolk.
I'm Nathan, and I'm also from Yolk.
I'm Alexander, and I'm also from Yolk.
Alright, yeah. Grabbing some photos of us and logos. Alright, let's talk about the first most fundamental thing. It's the control system. Control system of your robot is what causes your motors to move and your servos to turn. The control hub is the brain of your robot, and expansion hubs assist the control hub. There's also the option of using two expansion hubs connected together and with an Android phone acting as the control hub. Okay, so types of connectors. Basically, there's a lot of different connectors that people use for motors and batteries and basically anything that you're connecting. So there's a couple of common ones. This is called Anderson power pole. That's one of the common ones that people use for motors, connecting to other batteries and stuff. This one's called XC30. That's usually used for batteries, connecting them to control hubs and connecting the power from the control hub to the expansion hub. And then we also have JST, which is another thing that people use for motors, just to connect directly into the control hub and the expansion hubs. So a lot of people will solder their motors on, or their connectors off the motors to get JST so they connect just directly into control hubs or the expansion hubs, just to limit the amount of connections that you have, which makes it easier.
Then I guess batteries. So this year, most of the same batteries are the same from last year if you are a returning team. So there's the Matrix 12 volt 3000 mAh. And yeah, whatever. And then so those are available on like Go Build Robotics and Kidscale. Another thing to be aware of with these batteries, there's a second like version of them where the batteries are like offset. Those are not legal for first for some reason, but just be aware of that. And then there's also these, which are a very similar battery that are available on red.
These lower ones are flat, so you can fit them into a different profile.
Yeah, it just depends on what you prefer.
In terms of coding, you have Android Studio and on.java. On.java is definitely easier to use, but and easier to learn as well. But it has less features than Android Studio, and there's less opportunity for advanced coding, like using APIs and stuff. And this year, regarding odometry and like sensors and stuff, I would recommend using more of a vision-based approach to it, because if you use odometry, you can't go over the barriers with help. Whereas if you use like say AR Core from Google, an API which allows you to use vision localization, I bet you could go easily over that while maintaining accuracy on your robot's position.
What's your question?
Since we can't use standard odometry, and Intel's cutting support to their VSON, what do you recommend we do for odometry?
Probably just Google AR Core.
Oh, AR Core?
Yeah, using like a visual, like a different one, like Euphoria or AR Core.
Oh, before it is
Yeah.
also used for odometry?
Not with
Not odometry, but like
equivalent.
yeah.
We'll talk more about this later, but Google AR Core is an API for Android Studio that does like time of flight and depth mapping, which is basically vision-based odometry.
Okay.
We'll probably see a lot more of this. Yes.
Okay, so now we have some examples of good and bad cable management. So a great thing to do is actually color code your wires with tape so you know where they're going. It also gives them an extra layer of protection. You don't want them having a big jumbled mess like this, it just doesn't work. I could also recommend having a wire cage so you put all your wires together so again they don't turn out like this, or zip ties. Oh, yeah, okay, use some more. Yeah, so this is neat. I'm pretty sure they're coming out of a wire cage here. This, they are on top of the robot, and this really doesn't work.
Yes. So this is called a cable chain, I think. It just runs along your linear extensions and it unfolds with your slides. So if you draw your slides that move vertically, horizontally, they're great for protecting your wires along the same axis. This year we have the new driver hub, as we heard from Kickoff today.
It's a replacement for the driver station phone. So normally you have an Android phone that connects to a USB hub and then to up to two Logitech controllers or the remote controller. The driver hub has the USB ports built into it. We see that as a really big advantage because you have less points of failure, and we know that once you plug in and unplug the phone charging thing 1,000 times, it didn't really work anymore. The driver hub has also 5 gigahertz. Has 5 gigahertz Wi-Fi band as well as like 2.4, no, 2.6, which is better connectivity during competition. So most people are on the lower 2.4 band, which gets really congested, and then you'll have connection problems if there's interference. But this is not competition tested, so that is to be seen, but I think it has a lot of promise.
If you need help, you can go to sites like Gaming Zero. They have some of the best tips when it comes to electronics and hardware. You can go to the FTC GitHub. You can go to the FTC forums, the FTC Reddit. You can go to YouTube. There's a lot of helpful videos on the YouTube, and you can go to either the Utah Discord for FTC or the main FTC Discord.
And we have both of these links on the flyers and laid out for you guys, so you can just access them.
There's a Utah TV.
There's a Utah.
Yes, the Utah FTC socials are on the handouts that Laurel had.
All right, questions? Comments?
Maybe you can make a little bit on the that.
Go ahead.
Is Stack Overflow also a good resource or not so much for hardware?
On Stack Overflow, I feel like it could be a good resource, but I'm not sure how much actual information about FTC there is. But in terms of like basic coding, I'm sure you could get help from that.
All right. Does anyone want to cover some more fundamentals here before we go on to the more advanced stuff? All right. Start off, we'll talk about in electronics current voltage management. As your motor speed increases, as your motor speed increases, it increases current draw, or when your motor stalls, it increases current draw. Current, you have a 20 amp fuse on the batteries, and if this burns out, then your robot has no more power. So, in programming, there's something called current monitoring, voltage monitoring, and what you can do is that if you have a spike in the current, you can shut off your motors to prevent your fuse going.
And so a reason why you have a spike in current is if the motor like jams or something, like where you get like an element stuck somewhere in your robot, and you can just have the code automatically stop the motor before it burns the fuse out or something.
It's kind of a funny story, funny season. Last season there was a team called Perspective, Mark, you might know him. He burned out probably a couple dozen fuses on his 6-motor drivetrain, and he used current management to solve this issue, because if you got into even like a slight pushing match with a wall or a robot, then you would immediately lose power because the current would burn the fuse nearly instantly.
Luckily, the fuses are replaceable, and you can find them at most nearby hardware stores at 12, right?
They're 20 amp fuses.
And so I guess what you were talking about with Robometry versus AR core. So AR, like last year, what our team did, we used Vision. We used like some thing that we made in OpenCV, which is open source like Vision software, to localize our robot and basically know where we are at all times. And that was good, but it was a little bit slower than odometry was. That's the main advantage of odometry. And so with this year, it's so hard to use odometry because of the little PVC files that you have to go over. That Vision is a really viable option. And so Google AR Core is something that is kind of coming up because it's definitely going to be faster than something that you would try to make yourself usually, and it's really accurate if your robot's moving, because I guess it's based on, it's like, because when your robot moves, it will know how far each point is from your robot because of the change in distance of your robot or your camera, as well as the point that you're looking at.
Hardware-wise, we all have two eyes. If you cover up one, you notice that we don't have the same depth perception. AR cord functions off the fact that you can get more depth by having a moving single camera, and so you can plot the fields. And so time of flight and depth of field are about utilizing one camera that's moving in order to figure out how far something is from a visual input.
And it's also cheaper because you will only need one camera. You can do it with your phone if you are using a phone instead of control hub.
Yes, you can do this with a phone. So if you are using two expansion tubs and a phone, that is a great solution.
Yeah.
Oh wait, so when you say the camera's moving, is it just when the robot moves, or?
Well, it does have, it's more accurate as because it gets that perception, but if you have it initialized, that mapping can analyze points.
Alright.
It's pretty advanced. I don't know all the math behind it, but I trust that it works. Any questions? Yeah.
Would you say that gyros are also a good replacement for like odometry?
Built into the control hubs and I think the expansion hubs as well is the IMU control measuring unit. And that is basically a gyroscope. It allows you to text your position relative to another position, so it is a gyroscope. I'd say for just estimating your robot's position, using an IMU gyroscope is a good idea, but it does lack accuracy in the same way that odometry does.
So I would recommend like using the both like together. That's like what we did with our robot last year. We did like the camera and then the IMU. So this helped it be more accurate and just get better position on the field.
Yeah, odometry pods, the placement is important. This year, if we're using vision, we'll be covering most of all the motion directly from field targets, vision targets. Odometry pods, there are generally always three of them, so it's good for horizontal motion, vertical motion, and then rotation. So we have two of them covered for rotation, and then one in the other direction for if we're going to do more accurate gyroscope measuring, then I would just do just two in the same axis. And that way you know how much you go. Because we found that using just the IMU built into control hub would cause overshooting if we move really tiny at a speed that was reasonable for autonomous.
Yeah, it was usually a few degrees off, and like, especially in last year's game, like that could throw your entire auton off, especially because you have to shoot after it.
And your battery voltage is important when you're using the IMU because your motors will have more power. When they have more power, they force stronger.
Because there's also stuff like from modern robotics where they have a gyro separate that you can buy, and then you plug it directly into your control hub or expansion hub.
Yes. We haven't used those specifically as we usually use the odometry or just the built-in, to the robot. Yeah. More or less answered the question. Yes.
How hard is Google AR for to use in comparison to like VSON and normal odometry?
It hasn't really been tested, so we aren't fully sure.
What about VSON in comparison to odometry?
I'd say odometry is more simple to comprehend and just program. For the Google AR core and like the iSlam, I think most of the challenge revolves around implementing it into your code. And so you have to create the function to say like this is what I'm looking for to measure where the robot is in the field. So do I recommend it for all rookie teams? Probably not realistically, but I do recommend at least looking at it. It's definitely I think one of the largest learning experiences for this challenge this year.
Any other questions, comments? Again, things you're unsure about.
otherwise, I'll continue talking about it. Yes.
Just kind of going into a little bit more. You do want them to not be statically mounted onto your chassis, so they're not able to like come to the ground. You do want them to have some sort of a spring that holds them against the ground, because since we have multiple tiles, your robot's going to bounce just a little bit. And if they're just statically mounted, they're just going to bounce with the frame, so they're not going to get as actively moving. So just make sure that you have some sort of suspension to keep them touching the ground at all times.
So odometry pods, those are what we call like little devices that you use for measuring position on the field. Oh no, it looks like this, and you've got a wheel around here. So we have an on wheel that presses against the ground right here. It's connected to a pod, and it measures the rotation of the wheel using a encoder sensor, which plugs into a control or expansion pod. What you're talking about is important because we want to have downward force, because if there is a ledge from the foam tiles, then it will jump and you will lose accuracy. So springs are your best friend here. There's various ways to spring an odometry pod so that it is forced against the ground. You can do it from a distance, so if you were to pull this here, you can spring it in like that. I'm not very good at drawing. Probably doesn't make a lot of sense, but you want to have pressure contact with your odometry pods.
Yeah, the other thing with odometry is like occasionally it has like the potential to slip, so that would kind of mess up like everything that is going on. So just be careful of that, I guess.
Typically, and there's omni wheels in that. Wheels like this are used for odometry pod wheels because they can move in other axes without recording any motion. I recommend wheels specifically to check that are rubber rollers, because the plastic ones, they will just slide on the foam, and then you have to have a lot of pressure to keep them on the field. And I just thought, instead of springs, you can also use rubber bands for your odometry. Those are
So if you're using omni-wheel, you usually want you want two of them on each pod. So that way if you line them like this, then there will always be like, it will always be able to roll no matter what orientation it is, just to make it more consistent, I guess.
Electronics wise, some of you may know about electrostatic discharge, or DC, short, disconnect. Is generally caused when you have too much static buildup, and then all your electronics get reset or turn off because of the rapid discharge of electrons. The only legal grounding strap, which is used to generally mitigate this problem, is the red grounding strap, which is available in red. It's just a simple wire. You'll connect it to port on your control hub, wherever you have your battery connected. So my expansion hub, this is XD30 port in the corner here. The rev grounding strap will just plug into your extra port and then to a part of your robot frame that is you cannot ground your robot to the field. That is not allowed. But by having your primary electronics to an electron sink, if you will, keep it from your electronics from frying themselves. Any questions?
About radio interference.
Radio interference. Well, I talked about like the Wi-Fi bands, so 1.4 and 5 gigahertz bands. Other Wi-Fi interference that's outside of the venue, I'm not really sure about how like fatal that is. I don't have much to recommend besides.
If you're using the 5 gigahertz band, it should be reliable enough that interference shouldn't be too much of a problem. But if you're using the 2.4 gigahertz band, yeah, you may want to consider upgrading, because we had lots of problems with that the past few years. Just our robot disconnecting in the middle of games and all that. So I highly recommend the 5 gigahertz phone.
And configure that on your driver station or your phones within the little client that runs the programs for running your robots. It's the FTC driver station and robot controller apps. There is this little setting thing where you can configure whether it's 2.4 or 5 gigahertz, if that's specific. There are apps in the App Store that you can get that are just like spectrum analysis. Basically, your phone is always receiving these signals, and you can display it. So there are apps that show you what channels have lots of activity on them and what don't. We recommend during competition just check that, and then move your robot channel connect to a different one so that you don't receive interference in your unlocked position.
Also, like the new driver hub used to replace the phone you're holding the controller, so that might be much better connecting. We haven't tested it yet because we haven't gotten our hands on one, but we imagine it'll work pretty well.
There are short like tech videos on the Red website that talk a little bit about it.
And just like a control hub, the driver hub does eliminate points of connection where your connection can fail and you can have controller connection or your cable could just break entirely.
Yes.
We have a driver sub already, and I can say that it is really nice because one thing that you can do is you can connect to its Wi-Fi, and then there's a web address that you can connect to a web browser. So you can connect your computer to it, and then you can actually access your control hub and driver hub Wi-Fi. And that way you can change between 2.4 gigahertz and 5 gigahertz and the different Wi-Fi channels. So that's one thing that's really easy to do, and it's quite nice to do that sort of thing. And it's also sort of the same way that you're able to send code wirelessly between your computer and your robot. I don't think it'll work for on-bot Java, but I know that it does work in Android Studio. We've used that.
I think on-bot Java has the Rev specific hardware that you use to game your code.
Yeah, so the Rev hardware client is just an app that you can download, and basically it allows you to code in on-bot Java just directly on your control hub. So basically, if you use on-bot Java, all the code is going to be stored on your control hub, and so that's just something to mention because one of my friends actually last year, they lost all of their code because something happened with their control hub, and then that was the only place that it was stored. So they lost a lot of progress. Whereas Android Studio, you'll have it on your computer rather than on the control hub, and then you will upload it to the control hub separately. So that is something to mention, and also like Android Studio, it is a little bit harder to get a wireless connection to the control hub to upload code. There is some resources that you can find on Reddit. I know that's where I kind of found out how to do that, but it's just a lot. It is going to be easier to like wirelessly connect to your control hub with on-bot Java.
I think it's one of the first features I would do as a starting team is to have your code wirelessly upload. Because then you can have people working on the bot, and then you can also upload code at the same time. Yes.
Also, Rev does have a video about doing wireless code transfer from Android Studio to a control hub, and that's just on their YouTube channel. So you can go look it up there if you want to see how to do it.
Thank you. I haven't talked about batteries in like detail. Generally, when you charge the batteries, they'll finish charging at around 13 to 15 volts. The first volt and a half to 2 volts is always expended really quickly by robots, and so you have a stable voltage or more around like 12 to 13. When your robots reach around 10 volts, or when they drop like lower than 6 volts while you're operating the robot, that's when it's time to replace them, I would say, or remove them, because you slowly disintegrate the cells within the battery and they don't last as long. So keep your batteries above 10 volts and then check them off. Controllers. The controller that is widely used in FTC is the Logitech F130, F310. Simple controller, pretty low cost. The PS4 controller is also available this season, but this controller is a great starting controller and works well enough for FTC.
You
recommendations on battery chargers?
Battery chargers, that's a good one. I forget what it's called. What is it called? So there's a, I don't know who sells it, but there is a charging base. It can charge like 3 to 4 batteries at once, and it automatically measures how charged they are and it will turn off. Batteries are typically charged at I think like 1 to 1.9 amps. You want to charge them generally slower than you want, so they take a while to recharge, but your batteries last a lot longer. But look for those charging stations that do have the current monitoring and stuff, so that your batteries are protected. The simple like wall plug-in ones with a little transformer connected to them, I haven't had a good experience with those, and I do find it a good investment to do buy, although expensive. These pumps, which last really indefinitely. This year, we'll be seeing a lot of probably linear extensions, because that's how we'll get shipping elements onto the different levels.
I'm pretty sure you can use linear extensions.
You can, but you'll have to be inside the warehouse.
Yeah, you have
So
to be.
you'll have a linear extension just to get.
Yeah.
You can see the platform.
The warehouses, you must be entirely inside in order to pick up elements. And also, you have to leave them in order to be able to store on level 2 or the shipping.
And since we have linear extensions to do the levels, it's super important to make sure that you have good cable management, so either wire cage or wire chain, or just have them guarded by some way that will allow them to not be damaged, because replacing damaged cables can be a pain, you may not know which one is damaged.
Cable chain, I thought of an idea that I remember. It's, so, you know how tents are assembled, like they use like the sticks and you stick them together. You can do something similar to that where you wrap your wires around these poles with pivots and they fold down. So some of you may be familiar with scissor lifts. They lay flat and then when you squeeze the ends together it lifts up. You can scissor lift your wiring next to where the extension is trying to do, so that way your wires don't ever get overextended. I'd also say wiring is very popularly done underneath robots because you don't see it. It can be kind of messy. This year, if you're going over the 1-inch barrier, I would make sure that your wires are definitely either not on the bottom of the robot and more on the side plates, or have way more than 1 inch clearance, because everything that, even if you have 1 inch clearance, when your wheels are over it, you're gonna have less space than you think.
Any questions?
Do you know about like weights? How would you identify your own capstone?
I think you have to have your number on it.
I'm not, because I'm not a programmer, but how would you,
Vision. So like,
how would you train it so that it knows you're shipping all?
what you can do is just even something like FTC and then just detect the color. If it is a solid color, it's easy to detect. Or you can do is and then just train your what your whatever you want to look like. And then that's kind of like
Also for any rookie teams or teams who probably aren't as experienced with programming and maybe don't want to use OpenCV, you can also use red color sensors or distance sensors, and those would work pretty well, just like saying like if the sensor detects something within this range here, that and then compares it to a different range that knows that that's the object that's looking for. So you can do something like that to make it a little bit simpler if you're not wanting to, or you can't go into OpenCV at all.
Yeah, that is good, but the one thing that I don't like about that is just like you have to be closer to it. And so that is a perfect way to do it if you're a rookie team. But like for more advanced teams, I would recommend camera just because you can use the camera during initialization. And then so right when you click start on your robot, it will already know what the randomization is. And yeah, distance sensors and color sensors are a really easy way to do it if you don't want to get into vision.
Thanks for bringing that up. Pretty sure you're not supposed to be teaching some of it. Yeah, so sensors are pretty universal. They all have the same connectors. They connect to the rep control hub. When we daisy chain control hubs and expand hubs together, I think it's important that you know that there is a little bit of power loss when you're going across the hubs. It's minimal, but it's important. Last season, we were running 2 motors at very high RPM for launching the rings. And we had them originally connected to the second expansion hub, and we weren't getting enough power to actually maintain the RPM that we wanted accurately. So I would say you want whatever parts, mechanical electronics in your robot that you want to have the most reliability, connect them to your first hub that has the power. So your first 4 motors, typically I say most people put them on drivetrain. I would put it on like maybe even your linear extensions, because those will need to work the entire unit on a higher power than maybe the drivetrain. Any questions about like connectors and like what types there are, or if you should solder them? Okay, I'll stop. GoBuilda has been growing really popular. I personally like GoBuilda. The designs are really awesome. Their motors have these bullet connectors. They don't have any real blocking mechanism besides friction. Connect them to they sell a little cable that goes from bullet to JSTPH, which is just plugged directly into the hub. I recommend, instead of just buying the cables, just buy the connector ends. They're way cheaper, and you can solder them together, so you have less points of failure. Does anyone not know how to solder? Or like me to talk more about soldering? You all know how to solder? That's cool.
Good skill.
So Game Manual 0 also contains like basic resources on do soldering, but in essence, soldering has a soldering iron, and you have a little bit of conductive material that's
What?
it's just solder. It's just solder. And solder